Hi, everyone. I'm TJ Redding. I'm the founding principal of Heritage International School, or HIS for short. Now, in this video, I want to share with you um, a toy, something that I get to play with. It's one of the great benefits of my role as principal is to um, showcase some of the amazing tools that we have um, connected with HIS to help our students learn. So I want to be able to share with you a look into ClassAdapt. So ClassAdapt is this amazing, innovative educational tool to help students who would otherwise struggle with really complicated, abstract scientific concepts, and to be able to see what can't be seen, and to be able to do that in the privacy of their own home or wherever they choose to study, at the beach. So let me share my screen and you can have a look at this innovative learning platform. Okay. So this is an example of one of over 100 different simulations that have already been created by ClassAdapt to help students understand um, different scientific concepts. So as you can see, this is a 3D simulation of a intermolecular forces in the state of matter, solids, liquid, and gas. Now that's a very complicated way of trying to basically explain what we're looking at here, and the students can see this and move it around like I am here, is a water molecule, a collection of water molecules. And right now, they're frozen. They're solid. This is what ice, in a sense, actually looks like if we could see it right down close. Now, what we're going to do is we're going to look at these bonds down here. So this is what's holding all that ice together and makes it solid and strong, is that it's so tightly compacted. And you can see that the bonds are sitting around, the 600 plus. Now, what happens if we start to melt our ice? Now you'll notice it starts to change, the molecules start to wiggle and move. And so here we are melting, 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 and we're going to now turn it into a liquid. So it's no longer going to be ice. The ice is, in a sense, being turned into its liquid state. And you can see we're heating it up. I don't know if you can notice those little flames under the bottom that simulate the heating up of it. And you can see that water is then a lot more the movement of those molecules. All right, let's bring this bad boy up to a boil. So imagine we've got a pot on the stove. This box could represent a pot, if you will. And we're going to put it on the stove, and now we're going to take that water and we're going to bring it up to a boil. And notice what happens to the water molecules. Now, if you've ever put water in a pot and boiled it, you can relate to this. You can see how the water would start to churn and bubble, and bits of it would, as it were, drops of water would want to like jump out of the pot as it starts to really come up to this boiling point. You'll also notice that our bonds have really weakened down here, so that by half. So when we've got water in a boiling state, the bonds, the molecular bonds that hold that together have dropped significantly. They're weakened. Okay. Now, I'm not a science teacher, but I can see that. And I can see how clearly it becomes for the students. Now, you see this trying to escape? Let's turn this into a gas. So we heat the water up and it starts to turn into a gas. And of course, for our purposes, we've contained it so that it doesn't go all leaching out into the atmosphere. And notice how the bonds are really starting to break. We've gone from 600 plus down to just over 100. Now, whether you're talking about students at early primary school or whether you're talking about senior students in the most advanced aspects of their studies in science, would benefit from being able to see this, to demonstrate. And then obviously, depending on their needs or their ability level, you can, as a teacher, um, get them to calculate things. You can get them to simulate it in their own, say, kitchen. Um, we can use this in many different ways to help support the learning. And this is just one of, as I said, over 100 simulations that ClassAdapt has created to help teach these complicated science concepts. So, and you can see the little subtext there. So if you're teaching chemistry or you're teaching physics, for example, this would help. And so this is one of the countless number of tools, toys that we get to play with at his to help enhance the learning, to stimulate curiosity, to get the students excited about learning. And I hope you can see that something like that starts to make you curious, helps you to find joy in learning, help you to become interested in science and to understand it in a way that um, certainly I never got to see when I was in school. The best I could get was a diagram in a book with a bunch of balls and sticks. And I never really understood what it was until I saw something like this. So I hope you've enjoyed this video. I hope that you can see how powerful a tool like this could be to help support your child with their learning and to grow them in their curiosity and enthusiasm for science. So thank you for now, and hope we catch up again soon in another example of the innovations that are coming out of his.